Hi, it's Ms. Reese, and I am going over the Unit 8 practice test. So first, we have a 37 gone in this problem, and with our 37 gone, we are trying to determine a few things. First, the number of sides. So if it's a 37 gone, it's going to have 37 sides. Let me turn off the highlighting for that. And then we want to find the sum of the interior angles. So remember our formula for that is 180 times the number of sides minus 2. So that's going to be 37 minus 2. So on our calculator, we can do 180 times 37 minus 2. That's going to be 6,300 degrees. You could also just do 180 times 35. Each interior angle basically takes the sum, so that answer that we got, and we now divide it by how many angles we have, and that works for regular polygons. So we have 37 sides. There are going to be 37 angles. So 6,300 divided by 37. And we're rounding that to the nearest tenth if needed. So this would be 170.3 degrees. Now, some of the exterior, that is always the same, no matter what, no matter how many sides this is always going to be 360 degrees. And then each exterior, we take the sum of the exterior and divide it by how many sides we have. So we'll divide that by 37. And that's going to be 9.7 degrees. And you can find all of these formulas on your toolkit as well. Okay, so question 2 and 3 are also the same. They're using the same format here, but instead we're starting with the sum of the interior. So we basically need to take that sum of the interior and we need to set it equal to our formula. Well, our formula is 180 times n minus 2. So the first thing we could do, there's a couple ways you could distribute 180, or on both sides I could say, well, let me just get rid of this 180. Let me divide by 180 on both sides. Because remember, when we do that, we're kind of figuring out, well, in the shape, how many triangles did we start out with? Remember, based on the number of sides we have, there's always 2 less triangles. So let me clear out this calculator. We've got 10440. We're dividing that by 180. That's going to be 58. So 58 equals n minus 2. So we would need to add 2 to both sides to figure out the number of sides. So that's going to be 60 as the number of sides. So if we think about it, 60 sides, it would have had 58 triangles in it. So we would call this a 60-gon, and the number of sides would be 60. If you wanted to, you could recalculate that and check, well, if I took 180 and I did 60 minus 2, oh yeah, that gives me back that original answer. Good. Now the each interior angle, remember we take the sum of the interior, whatever this answer is here, and we divide it by how many sides we have. So let's go ahead and take that, 10440, let's divide it by, we just figured out we have 60 sides. That would be 174 degrees. Sum of the exterior is always the same. That's going to be 360. And each interior, remember we would do, or each exterior, we would take that and divide it by 60. Now, 2 ways to do this. If we did 360 divided by 60, we're going to get 6 degrees. And the other thing you can do or check is, do these 2 answers here add up to 180? And they do. Remember, each interior and exterior angle are supplementary. So you could have subtracted 174 from 180 to get 6, or just use that as a way to check your work. And with our last problem here, we are given each exterior angle. So we're going to use that to help us figure out, well, how many sides do we have? So we know that 360, because sum of exterior is always 360, we know when we take that 360 and divide it by n, our answer for that is going to be this 15 degrees here. Okay, so what we can do, if we did a cross product, it'd be 15n equals 360. So essentially, we need to divide both sides by 15. So 360 divided by 15, that is going to be, 360 divided by 15, that's going to be the number of sides we have. So in this case, our n is going to be 24. So now we have 24 sides. We call that a 24gon. And the sum of the interior, remember, is 180 times the number of sides minus 2. You can do 24 minus 2, or you can just multiply 180 to 22. That would also work. This will be 3,960. And then here, let's take that 3,960 for each interior and divide it by how many angles we have. That would be 165. And then you can just double check, do these two answers add up to 180? And they do. 165 plus 15 does give me 180. Okay, so on to the next problem. First thing you would want to do is figure out, well, how many degrees is inside of this pentagon? So pentagon has 5 sides. So we're going to do this for every problem where you're solving for angles or x's in the problem. So I'd first do 180 times 5 minus 2. That's going to be 540. Or you can have it kind of memorized. We know a triangle is 180. A quadrilateral has 360. Pentagon's 540. So we know the total number of degrees here is going to be 540. And then we're going to go ahead and solve for x. In order to solve for x, we want to combine all of our like terms. I'm going to create an equation. So we've got 15x, 11x, 11x, 20x, and 12x. So we're just focused on the x's for now. So I'm going to add 15 plus 12 plus 20 plus 11 plus 11. So I'm going to write out my equation for this, and my equation is going to be, I'm going to use the same color I highlighted with, 69x. And then let's go ahead and combine all of the other numbers here. So we'll combine our constant terms, 14, 5, negative 1, negative 25, and negative 5. So 14 minus 5 minus 25 minus 1 plus 5. That's going to simplify to negative 12. And we'll equal that to 540 degrees, because this is a pentagon. Pentagon is 540. Let's add 12 to both sides. So this is going to be 69x equals 552. We can divide it by 69 on both sides. It's going to be 8. So x is equal to 8. X equals 8. That's actually not in degrees. That's just x equals 8. And then what we are looking for is the value of y. So we're going to look at this angle right here. So what we know about these two angles is that they add up to 180. They're a supplementary straight angle pair. So what I can do is I can plug 8 into this one here, 15 multiplied with 8. Let's add 14 to that. And that will tell us what that angle measure is. So we've got 15 times 8 plus 14. And that's going to be 134 degrees. So that's this angle right here is 134 degrees. And I know these two add up to 180. So I could take 180 and I could subtract 134. And that means this angle here is going to be 46 degrees. This one here was 134 in total. And now 11y could be set equal to that. Okay, so I would say 11y equals 46. Divide by 11 on both sides, divide by 11. Now, if you put this into the calculator, 46 over 11 We're getting a decimal, so we want to keep it in fraction form, and we're just going to leave it. That's the exact answer. We're keeping it in the exact answer. So this would be 46 over 11. And just note that that's not degrees, it's just the value of y. Question number 5 here. We've got all our exterior angles. Remember the exterior angles, the sum of the exterior, sum exterior is always the same, no matter what. Sum exterior is always 360. So we're going to add all of these together and set it equal to 360. So that means we're adding the 7, 10, 5, 9, 4, and 5. So let's add all of our x's. That should be 40x. So combine all of my like terms with x's. Let's go ahead and combine all of just the regular numbers. We have a negative 30, we have a negative 80, negative 8, negative 50, and positive 8. And that's going to combine to negative 160, all set equal to 360. So we can add 160 on both sides. That's going to be 520, so 40x is equal to 520. Divide by 40 on both sides. And x is 13. Now it's asking for the measure of an angle with one arc on it. That would be this angle here has the one arc. So we just need to plug 40 into that. So we're going to do 13. We got x was 13. 9 times 13 minus 50. So let's plug this into our calculator. We'll do 9 times 13. And then we'll subtract 50 from that. And make sure you set it in parentheses as well. And that's going to be 67 degrees. And you could go ahead and plug it in to each of them and then verify that all of them add up to 180 as well. Question number 6, we know a triangle's area. Area, remember, is base times height, all divided by 2. And making sure base and height are perpendicular. Base and height must be perpendicular. Create that right angle, 90 degrees. So in this diagram here, we can't use 4 as a base. There's no segment that's perpendicular to it. We can't use 5 as a base. There's no segment perpendicular to it. But the 2 segments that are perpendicular in this diagram would be the 6. That side here is perpendicular to the 2. So almost imagine if you rotated it, 6 would be on the bottom, 2 would be like the height of that triangle. So essentially, our formula, I know this one is super simple, but when you set up the formula, make sure you can do 2 parentheses here. Base times height divided by 2, so our base is 6. Our height is 2, all divided by 2. That area is going to be 6. Oops, let me get a pen. So area equals base times height divided by 2, which is 6 square units. We're still going to use that idea of area of a triangle. So to find the area, now we're going area of a polygon. Area of polygon is base times height. So still base times height divided by 2, because that's how we find the area of a triangle. But then you just have to multiply that by the number of triangles that you have. So if this is regular, all the sides, this would be 11.36 as well. And then I'm just going to imagine we have this triangle here. Now in that triangle, we've got 17.28, that's the height, or we also call that the apothem of the figure. And then we also imagine, okay, well, we've got base, that's 11.36. We've got the height, 17.28. Now, the number of triangles that has is going to be 7. That is a 7-sided figure. It's a heptagon. And you can almost imagine creating that by drawing in all of the radiuses in the figure here. So So we've got 1 of those triangles, 2, 3, 4, 5, 6, and 7 of those triangles in total. That's where we got the number 7 here. So when plugging this in, I would set up, we've got 11.36, multiply that by 17.28 times 7, and then that's all divided by 2. This is going to be our total area, and we're rounding this to 1 decimal place. So this 0 here would round to 1, so 687.1 square units. Okay, we've got our regular pentagon here. Do that. First thing that we know is that each of the side lengths are 18. It's regular. I would say that this part here is going to be 18. Now, 2 ways we can do this. I'm going to draw this little half triangle here. We need to find the apothem, or what we call the triangle height of this little half triangle here. So I took 18, and I'm halving it because I know that this segment is going to be half of that. It's going to be 9. And this angle here, we call that a half central angle. And a half central angle is calculated by taking 360, which is a full rotation, and dividing it by twice the number of sides that you have. So in this case, it'd be 360 divided by 2 times 5, 360 divided by 10 essentially, and that's going to be 36 degrees. So anytime you're setting up a little right triangle because you're trying to solve for a missing piece, in this case, we'll solve for this, we'll call it x. You can use any variable you want, but that's the triangle height, or what we call the apothem. So we need an angle measure, we need a side length that we're solving for. So from here, we say, okay, from 36 degrees, this angle here, we've got 2 legs. This leg is next to it, the 36 degrees, that's adjacent. This leg is across from, that's opposite. And so this, when we decide, is it a sine, cosine, or tangent ratio, this one's going to be tangent, TOA. So we could say the tangent of 36 degrees is equal to the opposite side 9 over the adjacent side x. When setting up a cross product, x multiplies to tan 36, and that's equal to 9. And the only way to get x by itself now is to divide by tan 36 on both sides. So kind of remember that shortcut. When the x is in the denominator or variables in the denominator, you end up dividing. We've got 9 divided by the tangent of 36, and that's going to be approximately 12.387 degrees, because we're rounding this to 3 places. So we can put that here. Okay, now in terms of finding the area of the entire shape, let me just zoom out a little bit. The area of this entire shape, you can do the little half triangles, you can do the whole triangle. Since I already have this kind of half triangle filled in, I've got base times height divided by 2 times the number of triangles we have. So our base of that little half triangle is 9. The height of our half triangle is 12.387. We're using that answer. And then there are 10 of those half triangles, and that is all divided by 2. Now I do want to show you that you technically can use the full triangle. And what I mean by that is you can use this entire triangle here. If you did use that entire triangle, the base is going to change and the number of triangles is also going to change. Oh, my tracing skills are not great there. So this formula here, if we use that whole entire triangle, the base is actually 18, and then there's only 5 of those. So we'll get the same answer regardless if we're using half triangles or whole triangles. Okay, so our area, we're rounding to 1 decimal place, so that'd be 557.4 square inches. Question 9, we've got an apothem length here, and we've got our regular 11 gone. Notice as we start increasing the number of sides of our shape, it starts to look more and more and more like a circle. So we are going to draw the little half triangle inside of this shape. This little half triangle here. First thing we need to know is, okay, we've got an apothem of 14, so this is 14 here. That's like the triangle height. We need that angle measure. Remember that angle measure, the half central angle. So 360 divided by 2 times the number of sides we have. That's really 360 divided by 22, essentially. So let's give that as 16. I'll just do 3 decimal places for this as well. 0.364 degrees, 364. Okay, now we need to figure out this length here. So the area of this entire shape is, we'll do the base, which is x, the height, which is 14. The number of triangles is going to be 22, and that's divided by 2. And then I can show you what it would look like if you use the full triangle as well. So from that 16-degree angle, we've got this side opposite, this side is adjacent in the right triangle. So our ratio is going to be the tangent of 16.364 degrees is equal to opposite over adjacent. Now, if we did a cross product, x would equal 14 multiplied by tan 16.364. So let's get an approximation for x. X is approximately 4.110. I'll round to 111. I usually don't round to one place until the very end of my problem. It makes it more accurate. So 4.111. Now I can find the area of the entire shape. So we've got the base being 4.111. We've got our height, 14, 22, all divided by 2. So rounding to 1 decimal places would give us 633.1 square centimeters. If you did want to use the full triangle, so let me just point out here, you could use this as 11. You would just need to double this number here. So doubling 4.111 times 2, if we doubled that, 8.222. We still will get the same answer. So you can still use the full triangle and with 11 triangles, either way. We'll clear this. Question 10 and 11, we're using our special right triangle properties. So we've got our 30, 60, 90 with our short leg, our long leg, and our hypotenuse. So with our triangle here, I would start by drawing out and figuring out one of the little triangles here. So it looks like what we have is a short leg, that's 21. And what we're looking for is the long leg. So short to long, we multiply short to long. We multiply by root 3. So times square root of 3. That's going to be 21 square root 3. Okay, so now I'm going to find the area of this one little triangle here. And then I would say, okay, well, I've got 2 of those triangles on each side. I can essentially fit 6 of those triangles in total to my shape. So my area is the base, 21 root 3, times the height, 21, divided by 2. That's the area of just that red highlighted triangle, and then I have 6 of those triangles. Now, we want our answer in simplest radical form, so let's see what happens when we put this into the calculator. 21 square root 3. Whoops. times 21, all given 6, all divided by 2. So we don't want it in decimal format. We actually want it in simplest radical form. We want the exact answer. So what that means is we got to get rid of this square root of 3 here. So we don't want to multiply that out. So our area in exact format is really 1,323 square root 3 units squared, or square units, we'll call it. Okay, so just notice that that is the same exact answer, 1,323. That is the same answer as this one here as well. So these are the same decimal format, but this is just what we would call simplest radical form. So the way we get that is we take just the numbers here. We've got 21, 21, 6 divided by 2. That's how we get this number here. And then we are not multiplying out the square root of 3 because we want it in exact form. And on our last question, we're also going to be using a 30, 60, 90 property again. So remember our 30, 60, 90s. We've got 1, that's the short leg. 1 root 3, that's the long leg. And 2, that's the hypotenuse. 60 degrees, 30 degrees, and our right angle symbol there. So let's go ahead and draw this triangle in. I'm actually going to draw this triangle. I usually like to start with this one at the bottom. So this is our right triangle. This length is 10. All of the radius lengths are 10. So what we need is our short leg. So we're going from hypotenuse to short. That's half. We divide by 2. So 10 divided by 2 is going to give us 5. And then to go to the long leg, we multiply by root 3. This will be 5 square root 3. So then putting this into the calculator, we've got our area for this triangle here. We've got base times height. That's the area of just that red triangle I highlighted. And then I would multiply that. This is a half triangle, so there will be 12 of those in the shape in total. So we can clear this. And so to find our answer in what we call radical form, we want the square root 3 in the answer at the end, so we're not multiplying that out. So the only numbers we do multiply out are the 5, 5, 12, and the 2. So we'll get 150 square root 3, and this will be units squared. And so your answer that you're putting in here would just be the 150 root 3 square units, same thing.